So my name is Teja Bodepudi. So I'm a senior data scientist. So you can call me Teja, it's too long to call me. So I'm working as a senior data scientist working for the Infosys Limited. So I've been pretty new to the Dallas as well. I moved in 2019. I moved from Australia to here actually. So I moved from Sydney. Started liking this place because my son was born here. So it's good, pretty cool stuff. Then I started working with Infosys. I have a wide experience working across different areas like retail, telecom, and logistics, automobiles, a lot of other stuff I dealt with, and now especially the data stuff, so data and AI stuff. All right, I'm going to talk about the very interesting topic today: anomaly detection in IoT devices using artificial intelligence, machine learning algorithms. Right, it's pretty cool stuff, a very hot topic, right? So the anomaly detection is very cool. So let's jump into the slide. First, we try to understand what is an IoT. You're all familiar with IoT, right? I guess so.
Absolutely.
Yeah? So things which makes our life beautiful, right? So what is an IoT? Just talk about an IoT, right? So IoT describes a network of the physical objects that are embedded with sensors. Making a point, this is sensors, right? Connecting the sensors and different software and other technologies for the purpose of continuously sharing the data for different community over the internet. So that's where we use the IoT. So I can stand here, I can operate my garage from here, I want to close it off or close on, and I want to control my air conditioning from here. Thanks to the IoT making our lives more beautiful, right? This is happening on an everyday, day-to-day life with the Internet of Things. Let's talk about the industrial IoT. Right, so industrial IoT. So it refers to the application of the IoT technology. So basically, we are controlling the different sensors or any kind of stuff to make the productivity more increase by implementing the IoT technology in the industrial sector, by instrumenting of controlling of sensors and the devices to improve the productivity and also make the automated process and reduce the manual effects. So which is possible with the industrial IoT. So IoT applications in the industrial. As we can see, there are different sectors here. We can see it was implemented in many sectors, right? Automobile, factories, proving, agriculture, smart cities, everywhere we see the IoT. All right, looks good. Everything is working perfectly fine, right? What if anything happens in the middle? What if your system breaks? So working fine, the industry will be end up in a big loss. And your day-to-day life becomes really hard. As long as the technology works fine, everything works fine, it looks good. Things helps really good. But what? So I would like to ask you questions. What are the difficulties you face with IoT in your day-to-day life? So what are the difficulties you have with IoT? IoT is giving us a lot of benefits. You can operate anywhere in the world. You can control anything from your phone. You can do over the internet, anything you can do. But what if the process was being coupled or anything got happened in the middle? What are you going to do? How do we know this thing? So what are the difficulties you face in day-to-day life with IoT?
The network, the internet.
Yep. Mm-hmm.
Lagging, not working.
It's great. But what else?
Data, right? Because a lot of data is pulled from the user,
Mm-hmm.
and how is that being used?
Yeah.
Like who owns the data?
Yeah.
Who's using it, right? Privacy is gone.
Yeah, that's great.
Yeah.
So okay. Let's jump into what is. So you're gonna ask about the anomaly here, right? So that's called one of the anomaly. You talk about the security part. So anomaly. Let's first try to understand what is an anomaly here. So what is an anomaly? So let's in a two-dimensional data space, anomalies are the data points which exhibit different behavioral patterns from the rest of the data points. So you can see from the picture there, you have the two-dimensional space. You have different data points there, but you set up there's the right stuff there. Those are called anomalies. So it's going to be really hard to understand by looking at two-dimensional space. Let's give an example of a credit card transaction. So you, in a day-to-day life, you might have spent up almost a maximum of $100 or $200, let's suppose. Let's put it this way. One fine day, without your knowledge, someone has spent like $1,000 or $2,000 on your stuff. That's one of the anomaly, right? So if you don't know, how do we deal with these things? So anomaly is a pretty risk in any industry. It's going to be in normal day-to-day life of any human beings. Even for the industries, it's going to be really hard stuff, right? Anomalies. So anomalies, they don't exhibit the normal behavior. they're different from the usual patterns what the data is following. That we call it an anomaly. Let's understand what are the different types of anomalies we have. So we have a point anomalies, a contextual anomalies, and also a collective anomalies. There are 3 different types of anomalies. When we talk about a point anomaly, so I'm just trying to make you to understand what is anomaly, and we can talk about what are the problems in IoT, then we can talk about solutions there. Just to make a context of what is anomaly stuff. So the point anomalies is like a single point anomaly. If you have a bunch of data there, and a single point is differing from the behavior of the rest of the data, like as I mentioned, a credit card fraud, the amount spent, you spend like one day is totally different from the rest of the day, what you're spending for the rest of the life. That's called one of the anomaly. It's one of the point anomaly we're talking about. And the contextual anomaly, this is about the time series model, kind of like a forecasting stuff I'm talking about. So we can see an example there, right? So spending $100 on a food every day during holiday season is normal. But if you spend like 10 grand, it's going to be an abnormal, right? That we call a contextual anomaly. So because the contextual anomalies are pretty much deal with the time series, pretty much on the time basis, like on a particular day, how much you're spending, and looks at your historical data of last 3 years or 2 years, how does it work that? That's we deal with the contextual anomalies. And the collective anomalies. So collective anomalies, as Peter mentioned right now, so there was someone copies the data or the privacy things happen, right? So we treat that kind of anomalies as collective anomalies. Basically, someone tried to copy your data, a bunch of data points. They try to, the privacy was break and they try to steal some data, right? We always see in their day-to-day life, we're hearing, hey, the privacy was being compromised in the banking sector, different sectors. That comes under the collective anomalies. So there are 3 different types of anomalies because not all the anomalies, so anomalies can be treated as outliers, but not outliers, all outliers are the anomalies, right? Even your behavior can get changed from day-to-day life. That's why we segmented into 3 different anomalies to understand what anomalies we are fitting in. So I believe you guys have a good understanding of the anomalies right now. Let's jump into what is anomaly detection, right? So we know the IoT is doing pretty decent job, but if anything happens, the process gets changed, or the process get a problem, or if any sensor was stopped working, or it could be any kind of reason. It could be a security issue. It could be anything issue. That is where the AI comes into the picture, right? So AI, the artificial machine learning algorithms, will do a pretty decent job in anomaly detection. So what is anomaly detection? The process of identifying the patterns in the data which are different from the normal behavior. That's called anomaly detection. If anything goes, even though even though it's a normal behavior too, if it stands out from the abnormality of the traditional behavior, it gives an alerting system. That's called an anomaly detection. So we are trying to find anything which is exhibiting a abnormal behavior. We try to understand that. We'll do it as anomaly detection. So we'll talk about anomaly detection is implemented in various areas like IoT devices, sensors, with the fraud detection, intrusion detection, industrial damage detection, and medical and public health. Let's specifically talk about the sensors, right? So you have a sensor and you have the parking garage. It works on that. Someone tried to tamper your sensor. Oh, it stopped working. You can't come from here. You don't know. Because all of a sudden you found that you don't know what is happening with your stuff, right? The sensor was broken. And one day you try to do it access from your phone. You don't know what happened there. If it is with a simple thing, that's okay. It's not a big deal. You can solve it by going and fixing it manually, right? But think about it. If these sensors have been embedded into a industrial IoT, like a manufacturing units, you have a different processes going on, like manufacturing units, right? Different sensors have been embedded into different places. One sensor, because by trusting those sensors, but IoT, so the companies rely on these things. A lot of productivity will be lost if any sensors has been not working properly, or else if one of the sensors is taking a lot of power consumption, it increases the cost of productivity. It's overall a big loss. And even, let's put it this way, if any of this, the process of the sensors stop working, and by the time you realize and getting fixed, it's going to be a huge loss for any organization. Or it could be hard to understand what exactly need to be done, right? That's where we need an anomaly detection with an IoT in IoT. So that's where in the sensor side. And the fraud detection, let's understand if someone tried to break into the network, because IoT works on the internet, right, day-to-day basis, or any kind of a secure network. But still, if anyone tried to break into your network and try to steal your data, so control your things. Such kind of places, we want an alerting system immediately. Okay, something is happening there. We go and fix it. That is where the anomaly detection comes into the picture. And let's talk about smart city, right? So we all watch in the movies smart cities. Someone from different places, they control the smart city by taking off the power and by traffic controls, and all these things will happen. That's where we need a real-time fraud detection and intrusion detection to make our life very easy with IoT, along with the most secure way and increased productivity. That's where the anomaly detection is pretty much needed. So this is pretty much dealing with anomaly detection. Do you kind of feel any of this kind? You understand what is an anomaly now? What is an anomaly detection? Do you feel where do we need an IoT anomaly detection? So do you feel any other places where we need to implement an anomaly detection other than this stuff? I would like to hear from any of you guys.
I know a group that's written for, they've written for the doctors or the medical industry, where the dentist, they started off with dentists, and they just wrote an algorithm that can look at the EOB, the explanation of benefits, and they can see, they start checking what has been checked off on the EOB. And so if they're doing a lot of, let's say, children procedures, and it's a 70-year-old man that's in there, they know there's something wrong.
That's great, right?
It's a fraud. So they've done that, and they've gone to gynecologists, and the medical industry has really taken it seriously. That people, that doctors are, I apologize if your father or your spouse is a medical professional, but there's a lot of fraud in the medical industry.
So we need an AI for that too. So prevent. This is a proactively reacting on that rather than we reacting. We proactively working on the things, especially in the medical industry. We'll talk about a VIP. So he's a very important person for all the, as a political leader, or it could be a industrialist or something. He has a pacemaker on his body. Let's go. But if someone tried to take the control over the pacemaker, it's going to be really hard for a human being, right? It also affects the economy. It could be affects on a lot of stuff. So that's where we need an anomaly detection. It should happen on a real-time basis, right? So that's where we're heading up in AI with the IoT. It makes us our life beautiful and also more secure way. All right, let's talk about machine learning, right? So you guys, anyone know about what is machine learning here? So you might have heard a lot of things these days, machine learning, artificial intelligence everywhere. All right, machine learning. So machine learning is a sub-branch of the artificial intelligence and a computer science. So basically, which focus on the algorithms to get trained on your data and then predict the outcome of the future. That's where the machine learning we focus on. It's a branch of computer science. And so once you have a machine learning models, it gets trained from the input data. So the data you provide to the models, it gets trained on the input data, and then builds a predictive model. As you mentioned, the forecasting models, how it was built better. This is because of you have input data, you fed into the model learns the pattern from it, and it predicts the outcome of that. That's where the machine learning. So everyone thinks that it's a black box, right? What is happening with machine learning? It gives some results to you. But machine learning is the kind of stuff, it learns the patterns of the data. It's kind of like a mathematical calculation, statistical analysis. What was happening in the past? What kind of pattern it was being recognized in the data? So you learn the patterns from the data, you train. So basically, it's not like a software you're writing or programmatically you're writing. So you basically teaching. It's like a self-train, right? So the model itself, the machine learns from the patterns, and then it applies this pattern to the future data, which it never saw this before. And we can always do the testing out of that. There are different metrics like accuracy, precision, recall. We see how the performance of the machine learning model was working. And this is not like you're making a machine to learn by itself and then want to implement it, rather than writing a a programmatically algorithms to see, hey, you have to do like a robo, right? It's not like that. You learn from it and you implement it. That's the beauty with the machine learning. So there are two types of machine learnings. One is supervised and other one is unsupervised learning. Can anyone guess from the name itself, what is a supervised learning?
A lot of input, a lot of monitoring of what goes in and what comes out.
Mm-hmm. Very good answer, but what's the difference between a supervised and unsupervised?
A lot of human interaction on the supervised side. Unsupervised, the system is just doing its own thing, meaning analyzing the data and reprogramming itself to make it better.
You're almost close, but again, so as I mentioned, it's just like a machine learning, it learns from the input. Even unsupervised also learns from the input, right? So what's the major difference between supervised and unsupervised?
Curation. You're curating the data sets.
Supervised, I think you're teaching. You're telling it what to do. And unsupervised, it's doing it on its own.
Exactly, you're on the point. Okay.
Running a stochastic model as opposed to letting the model build itself. Yeah.
I got a deep dive into supervised learning now. All right, you can see the pretty decent example there, right? You have an apple, banana, that's your training data. So first, let's understand what is supervised learning here, right? Supervised learning, you have a set of input variables. When I call input variables, that's called features. You have a whole bunch of the features, like a whole bunch of attributes you put into a model. That's your attribute. And then we call it as X, as an independent variables. And there's an output variable Y, which is a, what do you call that? It's a dependent variable. So here we have an apple, banana. So we have a training set here. And we fed that into a machine learning algorithm, but we have a labels for that. We have apple and banana. So you should be able to learn from it, whether it's apple or banana, it should be able to do the classification from that. It already get trained on a label data. And then when we feed into a model like unseen data, it should be able to predict the banana, it's banana. So that's the prediction, right? So what basically a supervised learning does is, the goal, it has already a mapping. It knows the mapping between the input and the output. It learns the pattern from it, and then it predicates the output. That's a pretty much supervised learning algorithm does. So it has the input and output while it gets trained. And when you ask for a prediction, because the same data patterns, it predicts and then gives the accuracy there. And you're also able to do how your model is working. That's the supervised learning. You should be able to check whether your model is working, like how accuracy it was, what is your precision, what is your recall, kind of stuff you can do with the supervised learning, because you have an output data to test it out, and then you can implement on an unseen data. So pretty much supervised learning is you have a label data. Label means you have an output to understand what is the input and what is the output. You have a mapping between input and output. So unsupervised learning. So unsupervised learning is where you have an input features, but you don't have an output feature. So basically, you don't know what is the output. You only have input variables. Let's understand why. What is the importance of unsupervised learning? The goal of the unsupervised learning is basically to understand the underlying structure of the data distribution in the data points. As we can see in the unsupervised machine learning there's unlabeled data, right? You don't have an output while you're feeding the data into the model. The algorithm doesn't know whether what is the outcome going to be from that input. It only can learn the patterns from it. It's kind of like a clustering segmentation. So you have a bunch of inputs you feed, and then you can see the outputs, right? How it produces. It segregates out the apples and oranges. So kind of like you don't have an output variable. You don't train them. Basically, it itself learns the data from that. It learns the patterns, and you're not controlling any weights there. But in supervised learning, you have the weights controlling there. You make the model to learn based upon the weights and certain rules. But here you don't have the certain rules. You segment them into multiple things. That's where the unsupervised learning algorithms. All right, so these are the examples of the anomaly detections in IoT. So we already talked about this: intrusion detection, the fraud detection, and health monitoring, event detection, sensor networks, and ecosystem display. Right, we have an examples of anomaly detections here, and you also know there could be multiple anomalies we can deal with in IoT. But my question is, in a day-to-day, so do we deal with a supervised or unsupervised kind of learning here? I want to hear from you guys. So you know what is the difference between supervised and unsupervised here? So whether we implement a supervised or unsupervised for the anomaly detection in IoT.
Supervised.
Yeah, supervised to start with at least, to give you some baseline.
Yeah, supervised is good, but how about, do you know what is the output there? So you should be knowing, already having existing data, which is an anomaly, right? Do we have the data? So if someone tries to attack on your network, that data has to be recorded somewhere, right? Then only you can use the data to learn from it. But do we have that in a real world?
Chances are yes.
Yes, but what are the what percentage was that? Right? You don't know what is going to happen. You don't know what kind of anomaly it was. But I just listed out a few anomalies here, right? Intrusion detection, fault detection. But we don't know. It could be multiple anomalies. We don't even know what kind of anomaly was it. How do we know? Supervised doesn't know, right? Supervised, we have to feed the supervised to learn the model. What are the outputs we have? But it could be multiple anomalies. It could be just not like 5 or 6 listed out here, right? It could be something. There's a problem with electricity in the industrial things. Or it could be talking about a automobile car tracking, a tracker with the sensors, right? Or with the GPS kind of stuff. But someone tried to tamper it up. So tamper it, they don't want to know the car company to track where they are going. It could be kind of multiple things. It could be a physical damage, or it could be a software damage. It could be anything else. We don't know, right? That's the reason why. So we have to come up with an unsupervised plus the supervised. Supervised is basically, we can do it in 2 different things. First, we do with unsupervised learning. We understand the patterns, and we'll, from the base upon historical data, we can have the supervised learning. That's the. And let's talk about how to handle the anomaly detection. So you have an anomaly detection. We know what are the different kinds of anomaly detections there. At least we have a high-level understanding of anomaly detection. How do we solve this problem? There are 2 ways we can do. One is a classification, and another one is clustering. So do you guys know about what is classification here?
Anomalies that are similar in their characteristics, you put them in on one classification, or put them in several classifications depending on some way to identify them.
Mm-hmm.
Okay.
Yeah.
Clustering might be by time, or
Location.
or result of a certain action. You always get, or sometimes you get this kind of result, which is not normal for normal reaction. I'm just guessing.
Pretty close. But the classification, as I mentioned, the classification problem is like you have a whole bunch of data you feed into the model. You kind of have a lot of transactions are happening. You collect the IoT devices. You collect a lot of data points. You try device, cloud, or it could be anywhere, right? But we want to know. We are not interested in knowing what kind of it. We just want to know whether it's an anomaly or non-anomaly, right? There's 2 classifications, like a binary classification. What does model do? It just simply goes and reads the data, and it will predict it's anomaly or non-anomaly. That's the classification. Just a binary classification, yes or no kind of stuff. Whether it's a banana or it's an apple kind of stuff, right? That's the classification. Well, coming to the clustering part, clustering by name itself we can understand. It's like segmenting, right? It's not able to tell us like either it's a anomaly or non-anomaly, but it segregates out into multiple buckets or multiple segments. So kind of grouping the similar patterns, similar behavioral patterns of the or transactions or any kind of user behaviors into separate segments. That's called clustering. We have 2 different ways to deal with classification. Another one is clustering with this anomaly detection. But to deal with the classification, we need to have a label data, which we need to know at least the historical data where we have classified them as either it's a particular transaction or a particular sensor or whatever it could be. It has identified as an anomaly. That's where the classification we can deal with. Clustering is a thing, you don't have any information. You just started now your IoT industry now. You just started your pretty new, you started inserting IoT devices everywhere, but you don't have any history, you don't have anything, but you still can do the anomaly detection on that because you want to employ the security. That's where we come into the clustering problem. That's pretty much on unsupervised learning. So everyone thinks that, oh, machine learning can work only if you have it required. No, it still works on if you don't even have a whole bunch of the data, still you can work unsupervised learning, happen on an anomaly detection by making the feeding, whatever the data available, you continuously, you collect the data, whether it's anomaly or non-anomaly, you keep on feeding into the model on a real-time basis on a batch mode. The model can segregate them into buckets. But there are several use cases you can use this data for, not only for anomaly detection, but you can do for like a forecasting stuff, what is going to happen in the future. There are a whole bunch of stuff. But I want to limit here to anomaly detection because our main purpose of meeting today was to understand how the anomaly detection can be detected with the artificial intelligence machine learning algorithms. But there are a whole bunch of stuff. If you have a data sitting in somewhere, you can do a lot of things with the machine learning algorithm. All right, here's the solution for anomaly detection IoT. So we can see here, what thing, right? You have IoT systems everywhere. This could be for any industry, right? Not for one particular industry. It could be for a normal day-to-day life. It could be for a manufacturing unit. It could be for a car industry. It could be a smart cities, or for law enforcement, whatever it could be. The IoT systems here, right? The data is continuously fed onto this, and you have an ML, but deep learning models work on that, and then you will find whether there's an attack. There's a prediction. It will do the prediction and will send out the warning signal to the user. So it classifies them into a normal and abnormal. So you have systems there. It continuously collects the data. You put it somewhere, and you feed that data into an AML model that continuously tracks the transaction on a real-time basis, and it sends out, if anything abnormal, it feels that, it sends out an alert system to the user on a real-time basis. Then you can action on that immediately. Or else it could be, it's not like an intuition detection, right? It can be used for like, if any of your particular device is not working up to the mark, but your work is happening, right? But it could break completely, but you don't want to wait until the last minute. But if anything happens in the middle, or if the process is getting downgrading, the productivity is going down, or so it is costing us too much, it tells us in advance what particular area is causing an issue. That is where the AI ML models will help us. It makes our life more easy in increasing our productivity as well as the cost efficient. So you can see, right, on the second picture, there's an IoT devices there, and you have a data storage. So you continuously collect the data from the IoT devices, you store the data in somewhere, and you put a machine learning models on top of it. So if you have a labeled data, that's good. That classifies them into an anomaly versus non-anomaly, and then you can do evaluation. That's pretty much a supervising. When it comes to the unsupervised, you still have the same procedure, but instead of using a supervised, we use unsupervised learning. So we'll learn a good solution for the anomaly detection side in IoT. Question, please.
Yes, sir. Well, you've got the data coming out of data storage, and it's feeding into your machine learning model.
Mm-hmm.
Does the machine learning model require any kind of segmentation of the IoT data that's being fed to it?
No, so that's right. Like you have a supervised and unsupervised, right? So basically, it depends upon what is your use. When you look at this label data, it's already have a label data. That's a supervised. You don't do the segmentation or clustering there.
Okay.
You basically directly feed your features into a model. Model already knows about whether it's a label, it's anomaly or non-anomaly. It just predicts in advance. It says that this particular transaction anomaly or it's non-anomaly, basically. But let's suppose if you don't have a label data, that means you don't even have the history that whether something has been classified as anomaly.
Right.
You do the clustering there. You do the segmentation.
Okay.
Then you put it into separate multiple buckets there, basically. Then again, anomalies. I will talk about the different algorithms we can deal with the anomaly detections in unsupervised way. Then I'll go for the deep dive into that.
Okay.
All right. This is how the architecture works for IoT with AML, right? So IoT devices. Again, thanks for IoT making our life beautiful and more easy, right? But just want to increase the security as well as the productivity. We want to implement the ML algorithms. Again, because the IoT devices, the data is stored in somewhere, it's a cloud or it could be any platform. We just feed that into ML algorithms. ML algorithms will tell you whether the particular transaction or particular things was happening working correctly or not. It gives us a alerting system on a real-time basis to the user. You just act accordingly. So I'm just standing in front of you guys. If something happening to my garage, someone is trying to get in there, I get my alerting system here immediately. Oh, someone is trying to tamper your sensors. It's cost effective, right? Rather than someone is already broken and you go and fix it, it's going to be really hard. And by the time you do the things reactively, it's too expensive. The productivity is lost, everything is lost. But that's where we are doing a proactivity of implementing the AI/ML solution there on your IoT devices to improve the productivity, also the cost efficiency there. That's the pretty much architecture of the IoT with the AI/ML. We did it so it happens in a real time or a batch mode. The only the beauty thing with this integrating the IoT devices with the AI/ML is you're getting an alerting system in a real time basis. So the IoT is helping us doing our life more easy and flexible way. Along with that, we are improving the security with the AI/ML. That becomes a best solution ever had. All right, is anomaly detection supervised or unsupervised? So we know about supervised and unsupervised now. So kind of like whether you fail that the data you collect on a real-time basis from the IoT devices, how do we solve this problem? Do you think it's a supervised way or unsupervised way? Right. Typically, anomaly detection is unsupervised in the real world. Why? Because we don't have a label data. We don't know what transaction is an anomaly, right? It could be really hard for us to differentiate what is an anomaly versus a non-anomaly. By looking at a simple example of a credit card fraud detection. So if you're spending some money and someone tried to steal your credit card and then spend a lot of money on there, so we know that's one of the kind of the anomaly. That's a fraud one. But there are different kinds of anomalies, right? So we don't know what particular transaction was that, because a credit card, because most of the time you won't lose your credit card, right? So it could happen once in a lifetime, or it could be some. It's not like more frequently. That kind of transaction is really hard for us to collect those information. So for the banking or any kind of sector, it's going to be supervised really hard because they don't have that kind of data. They have to first collect this kind of data where these anomalies have happened, right? So that's the reason why in the real world you don't have this kind of data. So you basically deal with unsupervised way to deal with this anomaly detection. So once the enough data is collected and learned from the predictions of the unsupervised learning algorithms. So unsupervised learning algorithms will tell you whether this particular thing is anomaly or non-anomaly by clustering them into different buckets. Using those data by manually verifying, or it could be like kind of like a detection of kind of stuff. We can use that data to again feed them into a supervised model to improvise your accuracy there. So kind of like you collect the data from unsupervised, you collect the data from IoT devices, you feed them into unsupervised model. Unsupervised model tells into multiple buckets whether it's anomaly or non-anomaly. And again, you learn the labels from that. Again, you feed them into a supervised model to improvise the model. Okay. All right. So there are a lot of algorithms we can deal with unsupervised. So I highlighted a few algorithms here. We deal with anomaly detection algorithms, the most famous anomaly detection algorithms. The reason why I picked up the unsupervised anomaly detections today, as I mentioned, in the real world, you won't be able to see what kind of things was an anomaly or non-anomaly. We don't have the data. But we have a data, it's continuously feeding, but we don't know whether that particular data point was an anomaly or non-anomaly, right? So that's the reason why I picked up an unsupervised anomaly detection algorithms to make sure whether a particular thing was an anomaly or non-anomaly. So these are the famous algorithms I've used in my day-to-day lives, and I have written some research papers on these things. So this is the few algorithms or famous algorithms. It comes in the category of unsupervised algorithms. Even it doesn't have a label data, still you can detect the anomalies with this famous algorithms. One of them was the isolation forest, local outlier factor, and DB scan from one class history. These are all the machine learning algorithms. Basically, they are unsupervised algorithms. It kind of deals with like a clustering, as I mentioned it before. Let's jump into the isolation forest. All right. By looking at the picture, so can you draw some patterns out of it? How the model is working? Do you feel any anomalies there? Do you see any anomalies?
C3.
You can see, right?
C3, yeah.
Yeah. That's what the isolation forest does. So what does the isolation forest do? It's kind of like a isolation forest was basically like a decision trees kind of stuff. So basically it selects the randomly subsample data. When I say randomly subsample data, you have a lot of features like attributes collected from your different kinds of IoT devices. So what does this isolation forest algorithm does? It will pick up the randomly selected data and it will run some structures on the kind of like it builds like a multiple decision trees on top of it. So what does this do? When running the isolation forest on the stuff, if it goes deeper into the here, then it treats as a normal instance. If not, if it doesn't have a deeper tree, it doesn't have any further deeper down tree, then it treats as an anomaly. So we can see the samples that travel deeper into the tree are less likely to be anomalies, as they require more cuts to isolate them. And this will build up a lot of decision trees, like kind of like different kinds of trees it was being built, not like randomly structured data. So you have like 1 million kind of records. It will randomly pick up the records in a different structures, and then you will build a kind of decision trees, like a kind of isolation forest on top of it, and it will predicate whether it's an anomaly or non-anomaly. It's pretty good algorithm. So I work on a credit card fraud detection. Different works on a different the projects I worked on. This isolation forest really does a really decent job on the anomaly detection. It basically clusters them into different buckets. And also the beauty with the anomaly isolation forest is, so the good thing with the isolation forest is it also gives us this score. So a particular transaction or a particular record or particular data point is an anomaly or not. It also gives us a score. How does this happen? So you can see the space there. You have a different data points there. So this is how the anomaly detection happens. So look at here. We have the training observation, which is the white color one. The green color one is the new regular observation. What does the model do? The model is pretty much goes and tries based upon these things. And you can see the red things are falling different. So you're falling apart from the rest of the points. So those are treated as anomalies. This is how the algorithm works. It groups them together, the similar patterns of the data points together. So this is one bucket and this is one bucket. So the rest of the things you get this kind of data point which is falling apart from that. These are called an anomaly. But it could be a regular normal transaction. But maybe your behavior changes. I want to put back again into a credit card transaction because it's really easy to understand, right? Because on a holiday season or something, for Thanksgiving, you have a lot of offers. You spend a lot of money on that day, but you actually spend that. No one has did any fraud or something like that. But there's still an anomaly. It gives an alerting system to your phone. Hey, is that you? You're spending this much money. Is that you? Yes or no? You put yes, that's okay. If not, you can act on it. If not you, that's where these algorithms will do. Think about it in smart cities, right? If you're trying to make any changes in your smart city, kind of making some infrastructure changes, but we don't know who has done that. Or else, if it is a authorized person has done that, it's okay. Still, you get an alerting system there. Hey, something is happening. Abnormality. Is that? Do you know this thing? Yes or no? So you get an alerting system on a real-time basis with these algorithms, and then you can detect it in advance. It could be a normal thing, but some abnormality was happened. Any abnormality in the happens in the nature of the behavior of the data points, it detects in advance and senses the alerting system there. That's the beauty with the isolation fault. So it's kind of like a distance-based algorithms. It finds the distance between the normal transactions versus the regular transaction, and it separates them out and then put into a bucket as an anomaly detection.
What is the speed of analysis?
So when you call it speed, what do you mean?
Meaning, how quickly does it?
So we can implement this in real-time basis. So you have a real-time, near real-time, and a batch mode, right? So this is how depends upon your use case. Let's suppose because the banking system, you need it in a real time. If it's the manufacturing, you need it in real time. So it depends upon a use case. So
What is real time?
So when you say real time, the data is completely feeding into the, you already have your data continuously feeding into your data storage point. So if any new abnormality comes into the place, the model will take that point and say something has happened. You just go and react on that.
That's the second thing.
I mean, still better than worse, right? And you are still selling out a alerting system immediately, and you can go and act on it immediately, right?
So if it's a banking, I'll ask you a real bank example. The banking system, credit card I used in New York City, same credit card is used in Dallas. It takes a day for them to come back and say where you live. Even 12 hours is too late.
Yeah, but that's what I'm saying. If you can implement in a real-time basis, there is the way you can implement in real-time basis. That's what I'm saying. You still can do it in a real-time basis. You feed all the transactions in real-time basis. It sends out an alerting system on your phone. Hey, is that you're using in New York? You put yes or no for that, right? Then only the transaction will go through. So you can see the pending transaction on your credit card statement when you look at your phone when you purchase something. Even it takes like 48 hours. I'm not pretty sure about how long it takes for the bank to process the payment to the merchandise, but it's still there's a time there. So before that, you still can act on it. But when we say anomaly detection, it's not about the banking sector. It's about the manufacturing unit. Let's suppose the manufacturing unit, right? One of your sensor brakes stopped working, but still your job is working fine. But you want to know what is stopping your process there. What kind of anomalies were? You will know in advance, and you send out alerting system, and you go and fix it. What kind of thing is it? Or else you have to spend a lot of money on your manual transactions. Your manual person to understand, go and analyze what happened. If like one fine day you're good with your IoT devices, one fine day it breaks, you don't know what happened there. What kind of data point was being broken there? Or it could be a sensor, or you have like thousands of sensors, right? You don't know which sensor was stopped working. That's why the anomaly detection will pick up. Hey, this particular feature, this particular data coming from this sensor has stopped working. Just go and act on it. Makes your life more easy, cost effective, reduces the manual efforts there. The local outlier factor. This is one of the unsupervised learning algorithms. So what this algorithm does is it calculates the local density. So basically, it calculates the density between the data points with the neighbors. So you have a different transaction. So if let's talk about a manufacturing unit having a heating system. Like a certain temperature, it has to raise it to like maybe 100 degrees Fahrenheit or something. It will group them all together. Only one abnormal thing happens there. So that has been the local density, which has been having a lowest density. What this algorithm does, this is treated as an anomaly. It could be a normal, but an abnormal thing happens from the traditional behavior of the thing. So you treat it as an anomaly. It gives us an alerting system in advance. You just go and act on it. If it is normal, yes, you say yes for it. It's okay. But still, you're getting an abnormality alerting system there. So DBScan, this is also one of the density-based spatial clustering algorithms. So basically, these are so what this density-based algorithm does is, so it will look at all the data points, whatever the data you fed into it. It samples them into two buckets. One with anomaly and the other one is non-anomalies. The anomalies have been identified as like the algorithm will give us a -1. So then those transactions are treated as anomalies. So this is also one of the density-based algorithms. The lowest density calculated this is like a lot of mathematics involved in that. So whatever the lowest density between the neighbors, and it is treated as an outliers. So you can see, right, how this happens here. We have different clusters here. One of the clusters is one of the clusters, and these are the however. That's what we call minus one is the noise. All right, one class SPM. One class SPM is that it's also one of the unsupervised machine learning algorithms. So what does it do? It has a hyperlane to separate the two classes. We spoke about the classification, right? So one class SPM is the support vector machines, is the supervised learning algorithm. It learns from that. It was derived from one class SPM. Support vector machines are a verbal and labeled data. So one class SPM is the unsupervised machine learning algorithm. What does it do? The points lying outside this hypersphere are treated as outliers. So when you look at the data space there, you have a difference between the clusters, and what are the things that's falling outside the clusters are treated as the outliers. Pretty much on the one class SPM. So we treat all these as a clustering algorithms. So we segment them into based upon the behaviors, what the patterns are following. And if anything having a different pattern, which doesn't treat as a normal, that's just treated as an anomaly. Questions here. Let's come in. So we learned a lot about what is the kind of anomalies and what kind of anomalies we are facing with IoT and how do we detect them. We talked about structures, IoT architectures with the AML. Let's briefly look about the summary, what kind of things we can get on AML. To identify anomalies, normal observations need to be identified. If you want to go with the supervised machine learning algorithms, you want to know what are the things as normal, right? You want to understand, if you want to say something as anomaly, you want to know what is a normal behavior. And features need to be identified. If you say features, the features also means nothing but a data point. Whatever the data you collected from the sensors or anywhere, you just feed that into a model. That's called the features. And the label data can be prepared once we identify the potential anomalies from unsupervised learning. So we have an unsupervised learning on the top of it. We'll learn from the patterns from that, and we get the labels out of it. And again, we feed them into supervised learning machine learning algorithm to increase the accuracy. So as you asked me before, how I can wait for 12 hours, I can wait for 24 hours. This model can be deployed in both real time and batch mode. So real time means it acts immediately. If someone tried to get onto your network, you got an alerting system immediately. So when someone tried to hit the network from outside, which is an abnormal behavior, the ML algorithm takes the transaction immediately on a real-time basis, and it sends out alerting system. Please.
So, third bullet there is what's Bach. We can take an unsupervised learning and classify the data, cluster it, and then use that to improve our supervised. Oh man, fantastic! That's good stuff.
Yeah. Because we learn from unsupervised what are the anomalies and non-anomalies.
Yeah.
Again, you feed them back to the supervised learning that improves your performance there, basically.
Yeah, so we can kind of fine tune our
Yeah, exactly.
Yes. Okay. Excellent.
Any questions?
Now, do you guys have a product that does this?
So I have a research paper I can share with you guys. I've written a credit card fraud detection using a unsupervised machine learning algorithm. It's pretty decent. It's having around 90%, 90+% accuracy. And being unsupervised, having the accuracy of 90% plus is really good. So I can share that research paper to you. And also, the real-time I did this for the one of the telecom unsupervised, which is basically they give a massive contracts to bigger organizations. There's a lot of discounts being applied in the middle. What happened is sometimes we are getting a lot of underbilling. Instead of charging them like 100,000, they're getting charged $1,000. They can't go and see for each and every transaction because it's been done for worldwide. So underbilling sometimes it's going to be overbilling. The customers can leave the company because they don't want to pay the overbilling. They are not getting the applied discount. really hard to go and look at each particular transaction. Right? So one particular company, you give the contract, they might have 100,000 people under them. So we build the unsupervised machine algorithm on top of it. That does the pretty decent job there. And this can be implemented in any of your IoT. Only thing is you need data points, data. You have your IoT devices, you have a sensors, whatever the kind of the IoT device is. You collect the data, you feed into a cloud, just feed that into a real-time basis. That's the working example I can give you. Then that gives us an anomaly detection. So only thing is you have to have a API integration in a real-time sending a messaging. Yeah. That's the only thing you have.
So regarding that, what kind of framework were you using? Were you using like AWS SageMaker, or in terms of framework?
Even you can okay. So for building a model, you can do even a simple scikit-learn model on your Python stuff, right?
Oh, yeah.
Or you can do on an AWS stuff. Even you can do on Azure ML. You can do anywhere.
No, but
integrating
some of these tools are already there.
Yeah,
like
yeah.
SageMaker makes it easy where you're just putting the
Exactly.
formulas, right?
But you need a data scientist.
The formula is the hard part.
You need a data scientist to understand what is your data and what are the clean features you can pass it to your model.
Yeah.
Once the model was being built, you don't need a data scientist. So you don't need it. It's like a happening on real-time basis all the time. It learns from the patterns, and again you feed them into supervised. You can make it a semi-automated there. Yeah. So you feel it can work in IoT? I'm giving a real-time scenario. It worked in a credit card fraud detection really well. I took this from the Taggle.
Okay.
We have a data set available there. And so we have a label data. I didn't go with the label data. I went in unsupervised. The reason for that is real world you won't have a label data. You don't know what kind of transaction was an anomaly. So I built the unsupervised models on that. I'm going to share you the research paper written on that. Probably 90% above accuracy. Among them, the isolation first does really good job. And then you have a one-class system does is like 70% accuracy, but this is pretty good. So the primary goal of the anomaly detection is, it could be even an anomaly or not, but any abnormal situation happens, it gives us an alerting system. It notifies you. That's where the framework we're hitting there, to make our life more easy and safer there, and also not to break the whole system. It can be implemented in industrial IoT, it can be implemented in your day-to-day life. But in day-to-day life, it's easy you can go and manually fix it. But industrial IoT, you need this kind of anomaly detection models to make it automated process.
All right, great, guys.
If you've seen these